This is a bit of a long problem. It's a little bit repetitive as well, but it's excellent practice here. Okay, so here we have gases at partial pressures. Here they are. And we want to know what's the total pressure of the mixture. Let's do that first. So we know that P total equals P1 plus P2 plus P3, all the partial pressures. So that's not hard at all. So 215 millimeters of mercury plus 102 millimeters of mercury plus 117 millimeters of mercury. It does not ask us for a specific unit here, so let's just take the easy way. So the total would be 434 millimeters of mercury. That's the easy part. Now, it wants to know what mass, so that means it's going to tell us we're in grams, of each gas is present. And here's our volume, and here's our temperature. So we're going to have to do the same thing 3 times, so for each of these different gases. Okay, so we know that we have PV equals nRT. And it wants to know mass. Do we have a direct calculation for mass? We don't. What's the closest thing we have to mass in grams? That's going to be this one. So let's arrange our equations to solve for moles. N equals PV over RT. So let's do with nitrogen. All right, our pressure here, 215 millimeters of mercury. Can we do anything with that? No, not in gas laws. We got to convert to atmospheres. So 760, you got to know this conversion, is 1 atmosphere. Okay, so there takes care of pressure. Volume is going to be the same for all of these. Okay, R is always the same. 0.8206 liter atmospheres per mole Kelvin. Okay, so there our atmospheres cancel and our liters. Let's now divide by temperature. Oh, we're in Celsius. We got to get to Kelvin. 25 plus 273 is 298. So let's go ahead and do that. 298 Kelvin. Make ourselves a note. All right, now don't get an answer here. Just keep going. What does it ask us for? Grams. We have moles here, so just keep going. 1 mole of N2 gas is, I just did it in the last problem, 28.02 grams of N2. So see, that wasn't so bad. And we're basically going to do the same thing 2 more times. 215 times 1.35 times 28.02. Let's divide by 760. Let's divide by R. And let's divide by 298. All right, so with 3 significant figures, 0.43, round up to 8. 0.438 grams of nitrogen. Let's do it again with oxygen. Put in the same pressure here from the problem, copy the problem correctly. Most of the rest of this, same conversion to atmospheres. Same volume, because all the gases take up all the space in the container. 0.08206 liter atmospheres per mole Kelvin. Now we can cross off everything we've done so far. 298 kelvins. Now we need to be careful here. We need to go from moles to grams. So we know that 1 mole of oxygen is going to be 32 grams of oxygen. So just be careful on your molar mass conversion there. So pressure and molar mass is going to be about the only thing that's different. So 102 times 1.35 times 32, divide by 760, divide by R, and divide by 298. 3 significant figures, 0.237, don't round up. Okay, 0.237 grams of oxygen. And let's do it one more time for helium. Okay, 117 millimeters of mercury. Copy the conversion. I know if you're tired of writing, that's okay. Talk to yourself, talk it out. Helps you remember it. 0.35 liters. 0.08206 liter atmospheres per mole Kelvin. How do you think I feel? I know this stuff. All right, temperature's the same, 298 Kelvin. Units are our friends. 1 mole of helium. Let's get our periodic table. 4.00. Okay, so that cancels out the moles. Here we'll cancel out the moles and everything else. All right. Calculate. 117 times 1.35 times 4. Divide by 760. Divide by R. Divide by 298. All right, so this is a small amount here. 3 significant figures, 0.03. Got to round up to 4, and that becomes a 0. So 0.0340 grams of helium.